Here is an explanation for the answer to final exam question number 16 in physics, Demystified, second edition. If you have the printed book, please see pages 515 and 516. We're talking here about a basic circuit with an N-channel JFET. JFET, J-F-E-T, is an acronym that stands for Junction Field Effect Transistor, and this is the symbol for an N-channel JFET. N-channel you can recognize by the arrow pointing inward. In a field effect transistor like this, the source electrode is usually grounded, that's what that symbol is, and connected to the negative pole of a DC power supply such as a battery. A resistor goes between the gate, which is the control electrode, and the source, usually, not always, but generally. The drain is where the output is usually taken from, and it goes through a load like a resistor or a transformer that goes to another circuit. A circuit like this can take a weak AC signal and make it stronger in terms of voltage. It's a voltage amplifier. So this is an N-channel junction field effect transistor. This voltage typically on the order of 12 volts. Might be 6 volts, might be 18 volts. In a few cases, maybe a little more than 18 volts. But that's our circuit. Now our question is asking us, we can usually put a P-channel JFET in place of this thing and get a circuit that'll do the same thing as the other one did, as the original one did, if we do one of the things listed in our choices. A P-channel junction field effect transistor has the arrow at the gate pointing out. The answer to this question is that we simply reverse the polarity of the power supply. It's very much like the difference between a PNP bipolar transistor circuit and an NPN bipolar transistor circuit. The P-channel JFET operates with the same basic polarity as a PNP bipolar transistor does. The N-channel JFET, which we saw originally, operates with basically the same polarity as an NPN bipolar transistor does. But in this particular example, the correct choice is D.